Hello, in this video tutorial we're going to be talking about how we identify different types of quadrilaterals. And before we go any further, just remember that quadrilaterals literally means four-sided shapes. Okay, so we're identifying different types of four-sided shapes, but it's worth remembering that quadrilaterals is the term given to all four-sided shapes. Okay, so take a look at the screen. We need to make sure that we understand what is meant by parallel sides before we go any further. So let's read what it says. It says, parallel sides are sides that always stay the same distance apart and never meet, no matter how far you extend them. Think of them like train tracks. They run next to each other forever without crossing. So what we're going to do is take a look at the three shapes at the bottom of the screen and decide whether they contain parallel sides or not. So let's look at the red rectangle to begin with. And what we're going to do is compare opposite sides. So we've got this top side here and this bottom side here. I'm trying to carefully draw a straight line across each side. And what you'll notice is that the distance between those two sides, so let me indicate the distance, so from one side to the other, never changes. It's consistent. That means that if we were to extend both sides forever in any direction, they're never going to meet. Okay, so if that kept extending and if the bottom side keeps extending, they are never going to meet, are they? They're going to forever run parallel to each other and the distance never changes. Okay, so that shape definitely has one pair of parallel sides, but also if we take a look at the other sides, the opposite other sides, so for example this one here and this one here, it's a bit wonky, let me try that again. So this side here and its opposite side, we can see that those two are parallel as well. Okay, the distance between them will never change. They are parallel to each other. So therefore, that red rectangle has two pairs of parallel sides. Now, take a look at the next shape. We have this green trapezium. We'll explain why it's a trapezium a little bit later on. Now, I don't think we need to draw any lines here. Now, if you need to draw lines to work out whether or not sides are parallel, that's absolutely fine. But what I would encourage you to do is try to study it mentally. Does it look like it has parallel sides? Let's take a look at, let's call them side A and side B. Do you think those sides are parallel? They are, of course, parallel. If we were to imagine drawing a straight line on side A and a straight line on side B, it's clear that it wouldn't matter how far those lines extended, they would never meet. The distance between them remains consistent. So it definitely has one pair of parallel sides. However, let's call this side C and this side D. You should be able to notice that those sides are not parallel because I'm going to draw a line. If I were to extend it on side C and to extend it on side D, can you see that the space between them is getting more and more narrow as we go upwards and wider if we go downwards? Okay, so the distance between them are changing. Now let me use a different ink color so it's clear that eventually, if we extended long enough, these lines would meet and therefore are not parallel. Okay, so it has one pair of parallel sides, not two. And finally, we've got this yellow shape here, and we can call this yellow shape, for now, let's call it a parallelogram. I'll explain why it's a parallelogram in a minute. But can we mentally imagine how many parallel sides it has? If you can't, again, you can draw straight black lines on each side, if it helps you. But hopefully you can notice that side A and side B are parallel to each other. And also, side C and side D are also parallel to each other. Okay, so this shape has two pairs of parallel sides. Now that we understand what parallel sides means, this is really going to help us be able to identify any quadrilateral. Now, the 5 quadrilaterals that we're looking at in this video are on the screen. We've got rectangles, squares, we've got rhombus, parallelogram, and we've got a trapezium. And each of them has its own definition, okay? So what we're going to do is take a look at different shapes and decide what the name of that shape is based on the definitions provided on the left-hand side of the screen. Okay, so take a look at the first shape. We need to decide the name of this quadrilateral. Now, let's start with a rectangle. So take a look at the definition for rectangle. It says all angles are right angles. Now, a right angle is when 2 lines meet perpendicular to each other. In other words, they form this perfect L shape. It could be in any rotation as well. So it could be a standard L shape like that, or maybe it's an upside down L like this. But they must meet to form that perfect L, a 90-degree angle, okay? So a rectangle is all angles are right angles. Now, if we take a look at the shape in the screen, we can see that this shape has no right angles, okay? This is not a perfect L shape, is it? This is not a right angle. We don't have a right angle here, or here, or here. So this has no right angles. So we know not to call it a rectangle. Now take a look at the definition for square. It says all angles are right angles and all sides are the same size. It needs to satisfy both of those definitions. So it must have all right angles, which we already know isn't the case. So it cannot be a square, but also all sides are the same size is the definition for a square. And this shape does clearly not have all sides of the same size, okay? So we know it's not a square for 2 reasons. Then we move on to a rhombus. Okay, a rhombus is a shape, a quadrilateral, where all sides are the same size. And we've already established that this shape on the screen, our pink shape, does not have all sides that are identical, okay? They are not the same size, so we know it's not a rhombus. Then we move on to a parallelogram. A parallelogram has 2 pairs of parallel sides. Let's take a look. So let's compare opposite sides. So we've got this side here and this side here, which look parallel to me. So it's got 1 pair of parallel sides, and then this side here and this side here are also parallel to each other, okay? So it does have 2 pairs of parallel sides. Therefore, we can call this a parallelogram. Can we call it a trapezium as well? Because as you'll find out in this video, shapes can have more than one classification. Can we call it a trapezium? Well, be careful with this definition, because this definition says has 1 pair, okay? Not at least 1 pair, it has only 1 pair. Now, this shape has 2 pairs, so it isn't a trapezium. A trapezium has 1 pair. Okay, so this shape only has 1 classification. We call it a parallelogram. Okay, let's take a look at the next shape. So let's take a look at our definitions. We'll be a bit quicker this time because we've gone through all the definitions. So rectangle. Are all angles right angles? Yes, they are. We can see that they all form that perfect 90-degree L shape. So this is definitely considered a rectangle. Then we've got square. All angles are right angles. Yes, we know that all angles are right angles, but does it satisfy the other definition? Are all sides the same size? Yes, they are. We've got 10 centimeters at the top, and therefore the bottom must also be 10 centimeters. We've got 10 centimeters on this left side, and therefore on the right side must also be 10 centimeters. So it satisfies both definitions. Therefore, we can call this shape a rectangle, and we can call it a square. What about a rhombus? Now, a rhombus is just a quadrilateral that has all sides that are the same size. And we already know that every side of this shape is the same size. Each side measures 10 centimeters. So we can call this a rhombus. What about a parallelogram? Does it have 2 pairs of parallel sides? I think you can probably see that it does. It does have 2 pairs of parallel sides. If you take a look at the left side and the right side, you can see that they're parallel. And of course, I don't need to draw the other lines, do I? You can see, you can mentally imagine those black lines stretching across the top and the bottom. They would indeed be parallel. Therefore, it has two pairs of parallel sides. So this shape can be classified as a rectangle, a square, a rhombus, and a parallelogram. So it has four different classifications. Okay, and finally, trapezium. Now we've already established it has two pairs of parallel sides. A trapezium has only one. Therefore, it isn't a trapezium, but it can be classified the other four. Okay, so rectangle, square, rhombus, and parallelogram. All right, for this next shape, what I'd like you to do is pause the video and tell me, or write down somewhere on a piece of paper, or mentally think about it, what are all of the different classifications we can give to this shape? And once you think you figure it out, please resume the video. Okay, so we can call this shape a rectangle because all of its angles are right angles. We can't call it, a square, because although all of its angles are right angles, not all the sides are the same size. For that reason, we can also get rid of rhombus. It can't be a rhombus because it doesn't have four sides that are equal in length. But it does have two pairs of parallel sides, so we can call it a parallelogram. And because it has two pairs rather than one pair, we can't call it a trapezium. So we can call this shape a rectangle, and we can also call it a parallelogram. Let's move on to the next one. And once again, please pause the video and have a go at classifying this shape all by yourself. Okay, let's go through it. Is it a rectangle? It can't be a rectangle because it doesn't have any right angles. And we know that a quadrilateral must have four right angles. Is it a square? Nope, because it doesn't have any right angles. Is it a rhombus? Nope, because not all of the sides are the same size. We can see that the top and the bottom are definitely different size, can't we? Different sizes, so we can get rid of rhombus. Parallelogram, does it have two pairs of parallel sides? Let's take a look. Well, we know that the top and the bottom are parallel to each other. We can see that, can't we? The top here and the bottom here, those sides are parallel. However, the other sides on the left and right, they are not parallel to each other, because if we draw that straight black line, we can see that the gap or the space or the distance between them becomes more narrow as we go upwards and wider downwards. Okay, so they are not parallel to each other. So it has one pair of parallel sides and therefore must be a trapezium. Okay, and finally, can you pause the video for the final time and have a go at classifying this shape, and press play when you're ready. Okay, is this shape a rectangle? Well, does it have four right angles? Nope, it has no right angles, okay? And because it has no right angles, we know it's not a square. Is it a rhombus? Yes, it is a rhombus. It's a rhombus because the top and the bottom both measure 7 centimeters. And the left and the right side are equal as well, aren't they? And they both measure 7 centimeters. So each of its sides measure 7 centimeters, and therefore we can call it a rhombus. Is it a parallelogram? Let's take a look. I'm going to draw my lines. Let's use a different color so it doesn't get so confusing. Okay, so this side at the top and this side at the bottom are parallel to each other. And on the left hand side and on the right hand side, they are also parallel to each other. I do apologise if the working out's a little bit wonky, but that's why it's a good idea to try and mentally train yourself to look at these sides for what they are and not having to rely so much on drawing these lines. But you should be able to see that the opposite sides are parallel to each other. So we would call it a parallelogram. And because it has two pairs of parallel sides, it cannot be a trapezium. So this shape can be called a rhombus, and it can be called a parallelogram.